Hey, good morning. Um, Happy as always to see that a couple of you can join me for the live stream. So, very, very much appreciated. Thank you for doing that. Good morning, that one kid. Nice to see you. This class, CSCI 25, we have this week and next week new content. And then uh, the last week of the semester, we will do a review like I did for the midterm. We'll have a review um, 2 weeks from today, uh, preparing you for the final exam. So just so you know, that's coming up. The final exam week after next. So during the regular finals week, and it'll be um, similar to the midterm experience. So the final exam will cover all of the labs from week 10 through week 16, which is next week, which is the last week of new content next week. And then you'll have the final exam will open up that Monday morning, and then it will, the deadline for it is Sunday, December 18th before midnight, like the whole semester has gone. And the only thing going on in this class during the week of finals will be the final exam itself, and I will do a review during the live stream that Monday. So that's 2 weeks out. So this week and next week we have new content. This week also is the week that the distribution project comes due. So that's at the bottom of my agenda. That's December 4th. It is due before midnight, just like all of the week's assignments are due. So I've been mentioning it for weeks and weeks and weeks. This is the week when it finally comes due. So hopefully that's going well for you. I did receive a submission, and I went ahead and read it, and it was very, very, very well done. So can't name the person on the live stream or in the video, but anyway, that the person who has submitted, and there's only been one of you so far, who submitted your distribution project, it was very well done. It addressed all of the questions. It was written with complete sentences and nicely written. The person had used the same kind of approaches that we use in class to evaluate the system, installing some software packages like CalSay as an example. Evaluating the user interface. The research was very, very well done. So anyway, hopefully everyone has a similar experience where you just take kind of what we've been repeating all semester long and add with that some research about your chosen distribution, and then you'll get the same kind of result. It was very good. So anyway, I'm hopeful that everyone else gets a similar result on their distribution project. Okay, so this week, I guess I'll go ahead and walk through the module, but there's no big surprises this week other than don't forget the distribution project is due on Sunday with the lab and the discussion for this week as well. So this week has got that extra bit of work to do. So please make sure you allow for it in your schedule. Week 15. So we are talking about, I decided to switch the order from what it's written on the screen, but anyway, we'll talk about the null device, which is dev null is useful for scripting purposes, and it's also sometimes useful when you are issuing commands at the terminal. And I personally have discovered, when teaching it at least, that if we talk about the find command creates good opportunities to explore the utility of the null device. So find in combination with dev null actually work well together. I think it's understandable for the larger number of people what dev null is for if we start using it in conjunction with the find utility. We'll also talk about, so I decided to do inodes and linking first because that will go faster. Inodes is simply, that stands for index node, but really an index node or an inode is information about a file or directory on your system. And we will use our basic understanding of inode information when we do linking, because it helps, inode information helps understand the difference between a hard link and a soft or symbolic link. Linking, if you are on a Windows machine or you are a Windows user, linking is akin to shortcuts. So you do add a shortcut to the desktop. Your desktop probably has shortcuts to many of the applications in your system. And that's often how we use linking in the Linux world too. We create a link that is a shortcut to something, some program or utility installed somewhere else on the system that's less convenient to get to. But we can also use linking to share files and directories sometimes. We can use linking so that we can have multiple users have convenient access to the same information on the system, and then they can collaborate in working on that piece of information. We're just going to get the basics about linking, but most of you, and Mac, I guess, probably has the concept of a shortcut. I don't know. I have to think about that one. But anyway, we'll do it in the Linux world, and that's the thing that matters in this class anyway. Okay, so we'll do linking first because I thought that would go faster, and then we could relax a little bit and not rush our way through using the find utility and then using dev null in conjunction with find. Okay, so sorry about the number of readings. It's a 20-question lab as always, so just the readings I wanted to make sure and put together as much information as possible because the linking concept for some people is difficult. The null device concept for some people is difficult. And then the find utility is actually, in my opinion at least, it's one of the cooler utilities on the system, but it is one of the more complicated ones to use for all of that it's worth. So anyway, that's why a lot of readings, because I wanted to kind of back up all of the concepts and the tools that we're using with extra information. So sorry about that. That doesn't happen very often, I don't think, but I tried to make sure that you had not only me telling you about it, but plenty of sources of information to back that up. Lab as always, hands-on experiments. I noticed, by the way, I had failed to link in the actual document. So if you're ahead of me and you've already worked through this, then you may have found that the hands-on experiments were missing. They are there now as of this morning, so sorry about that. Most of the hands-on experiments are kind of a one extra step into the scripting world, and we will write what are called shell functions using the find utility that we're going to experience today during the live stream / lecture. So anyway, we'll take the find utility and dev null, and we will create some shell functions, which are another means of doing shell scripting work on the system. So that's what all these hands-on experiments are about. And I'm going to leave this open so I can refer back to it in just a bit. Anyway, so that's there now. Sorry it wasn't there when I got up this morning. It was a blank page. I had forgotten to link in the content. Now it's there. Okay, so discussion this week. It's kind of a way that I do a little bit of review on the course content, but really it's kind of a follow-up to the poll that we did last week. So in the poll last week, I asked you what you found the most difficult. Bash scripting won, and I think that's fair because Bash scripting is very, very sensitive about characters and spaces, and there are alternate syntaxes, meaning that there are actually different ways to write if statements, for example. And you'll see different people use the different ways of doing things. So yeah, Bash scripts are complicated and they are touchy and they can be frustrating. Vim got a few votes, and I think that's fair as well, because unless you sort of commit yourself to using Vim a lot and you really develop muscle memory for it, it's just kind of a pain in the rear editor to use. But I still think that there's two reasons. I sort of have a new reason that I thought of, but the two reasons why I think that Vim, I still think it's valuable to have some exposure to it, is that it is reliably the universal text editor in Linux and Unix. So you sit down at a Linux or Unix-based system of any sort, including like Cisco networking equipment, there's a good chance that you're going to find the VI editor in there so that you can do productive work. There's much less a good chance that you will find the other editors that compete for your attention in the Linux world, like Nano or Emacs. So anyway, I still believe that VI is more or less a universal text editor in Linux and Unix, so it's good to know how to do the basics. The other reason is so that you can, at the very least, engage in debates with people about which is the better and worse editor. So now you can say, I prefer Nano, and I know how VI works, and this is why I prefer Nano. Which is a thing that we techie people like to do. We like to debate with each other about our preferences and why what I like is better than what the other person likes. So now you can back that up with hands-on experience in VI, either liking it or disliking it. So that was another reason I thought was useful. It is a useful reason to experience it in a basic Linux class. All right, and then last, so lab this week as always, discussion as always, and then the distro project, which I have mentioned many times over the last many weeks, going back to the beginning of the semester, that is finally due at the end of this week, this Sunday before midnight, the same deadline as all of the other assignments. So please leave yourself time to do that. There is a fair amount of research. There is some keyboard time needed to sit down on the installed system of your choice and look around, install packages, see what that feels like, see if there's a graphical user interface, what is it and what features does it offer. All that stuff, it takes time, and you'll get a better result if you don't rush, but you know that. So yeah, that's where I'll leave that. Okay, so let me switch over to virtual machine view and talk about inodes and then linking. Okay, make sure that you see what I see. By the way, that was a little screen lock feature that came with the display manager that we're running. So that's kind of a nice touch. It was an automatic screen lock that timed out after a few minutes or something. Okay, so inode, I-N-O-D-E. We'll do some reading on it so that you will get reminded of the greater details. But the way that you view inode information is actually by doing listings. So the name of the thing itself is part of, I believe, what's inside of an inode. And here we see there are directories and there are files. The way you can get additional inode information. So just imagine desktop documents, downloads, file1.txt, file2 copy, file2, file3 music, all of those things. Each of them has its own inode or index node that contains extra information about that thing on the system. These are entities on the system. Files are entities that contain data inside of them, and directories are also entities because they contain references to other files or directories inside of them. We can see a little bit more information that an inode would contain by doing a long listing. So if we view a long listing, we can see things like when the file was modified. That's the 905, 905, 905, 852 stuff. We can see the size of the file. We can see the user owner and the group owner. We can see the permissions on it. But for our purposes, what we want to see is the index values themselves, the inode numbers themselves. So that number next to all of those entries that I got with ls-I is actually the index number, the unique identifier for that resource on the system. So desktop, its inode ID, its unique identifier is 401969. If I go from right to left, so file3.txt, its inode number is 397213. This information is not super useful in and of itself. Knowing what these inode numbers are doesn't really do a whole lot for someone at the sitting here at the terminal typing commands. But it is useful to better understand how linking works. So the reason why I introduced inodes this week, and the reason why I just brought up the inode values, in fact, let's look at the reason why I'm doing this is because I think it helps a person understand better what the different kinds of linking do. Let's bring up the man page and let's go down and read what the -I option tells us it is. Okay, so put it at the top. So -I or --inode, print the index number of each file. Now this says file, but you have to kind of remember that a directory in a way is a file. It's just a file that contains references to other files as far as the file system is concerned. So a directory is a special kind of file because it doesn't contain content in itself. It contains references to other content. But a directory still has an inode index number, just like every file does. All right, so that's ls-I, and I went and looked at the man page to read the little description of it. Now let's make a folder 15 for this week, 15, and just kind of get clear of all the other content. So nothing here right now. And now let's go do some linking. So to do linking, in a Linux or a Unix system, you use the ln command. So let's look at the man page. I've always been confused about what the difference is between the target and the directory, although this man page is a little bit better. So make links between files. Kind of think of that as being something like a shortcut, although in Linux there are two different kinds of links. So a shortcut in Windows is a symbolic link in Linux. I don't even know if Windows has the concept of a hard link. And Mac OS will have the concept of hard and symbolic links because underneath Mac is a Unix system. So all of this stuff will actually work directly on your Mac in the terminal if you want to play with it. Anyway, the ln command, make links between files. So if we look at the first line of the synopsis, we have options, which are optional. That's why they're in square brackets. -T is optional. It's in square brackets. But then what's required is a target and a link name. And for some reason, this always just confused me, although the man page has been updated a little bit to make it less confusing. So the target is the thing that already exists that you want to link to. The link name, of course, is the name that you want to apply to the link itself, to the shortcut part. It used to say target and source, and that always confused me because I didn't know what the difference was between the target and the source. So if you ever open up a Linux or a Unix system and you see the man page says target and source, then you'll feel my pain because that always confused me. So I'm very happy that the man page has been updated to say target link name. So then what you want to call the shortcut comes second. Okay, so in the first form, create a link to target with the name link name. That's good. We don't need to worry about any of the -T's, but we are going to use the -S. I'll put it at the top of the screen here, symbolic. So make symbolic links instead of hard links. So the way to figure this out, in my opinion, you could go read about it, but it's easier if you just make hard links and you make symbolic links and then you view inode index numbers, and that helps a lot to understand what the difference is. Okay, so let's clear. There's still nothing here, so let's just touch file1.txt. So file1.txt, and now I'm going to make a hard link to file1.txt. Oops. The thing that already exists first, and then what do you want to call it? I'll just call it link1.txt for starters. So link1.txt, the .txt is not required. I could even call it .link if I want to. Linux doesn't care about that stuff, but since I'm linking to a text file, I think it is useful to remind myself that I'm linking to a text file. Okay, so now I have both of those things. If I do a long listing on them, it's not apparent that one is a link to the other. There's nothing in here that says one is a link to the other. So this is where, uh-oh. I hope I'm still alive. I don't know if you guys saw that on the stream. Okay, so yeah, my graphics bombed for just a moment and then came right back. Fortunately, okay, so I didn't say anything. I just said uh-oh and then sat here. Okay, so I've just created a hard link, but if I do a long listing, there's no indication that one is a link to the other. There just isn't. If I do, though, uh-oh, my virtual machine is stuck and I have to reboot it. Yeah, I'm going to have to reset this. Okay, now I'm having problems. All right, sorry, I've got to reset my my virtual machine. So, moment. And that mess on the screen will go away in just a bit once I get it booted up again. What was the source of that? I do not know. There we go. All right. Sorry, everybody. We'll see what remains of the work that I just did. Okay, they're both there. So anyway, long listing. I know I created a hard link because I typed the link command to the original file called link1, but there's no indication here until I look at inode numbers. So if I look at inode numbers, one thing I will notice is that they are the same inode number. So this is weird that this could possibly be true, but a hard link is actually just another name to the exact same resource on the system. Now that at face value sounds like it would make sense, and oh well, isn't that obvious what it is? A link is a reference to something else on the system, but because they have the same inode number, it actually is that thing. So what hard links actually do is they count how many references there are on the system to this exact thing. And once those references go down to 0, then the thing can go away. I'll give you an example. So I'm gonna edit it. So hello, I am a linked file. So first thing I'll do is I'll just put some content in. I'll write it so you can see that's file1.txt. Okay. And then if I open up, in fact, let's just use cat to dump its contents. So there's the contents as we expected. But if I remove file1, link1 is still there with all the content in it. So this is something to keep in mind because in a moment when we do a symbolic link, it's not going to work the same way. So hard links are simply different names to the exact same thing. They are the same thing, which is weird. How do you have two names for one thing in a way? But that's how the hard links work in the Linux system. They're actually the same inode number, which means they are literally exactly the same resource. And as long as there is one link to that resource, then the resource with all of its contents will survive. So let's quit that. So I am in the week 15 folder. There is the link one. That's the only name left to that resource. Same inode number. So now if I go back a folder and I link to so I'm going to do a new link1.txt. So now I am in one folder back. I'm in my home folder. I have created a link from here, hard link, to link1.txt. Even though I know technically link1 isn't a link, it's just another hard reference to the same resource. But if I do an inode listing on new link1.txt, it's 451.734. If I do it for 15, same inode number, they are the same resource. So I can actually remove link1.txt. So it's no longer there. But new link1.txt here is because it's simply a different kind of tag on the same resource. And if I go view new link1.txt, it's the same content because it's literally the same file with the same inode index number as that original file one. So hard links are interesting because what you can do, for example, is if you had a whole bunch of users who needed to edit a single file, you could hard link to each user's directory to that one source file. As long as they had the right permissions, then they could all edit that one file collaboratively. And if those users kind of dropped off the project and you remove their accounts and remove the link, you don't remove the original file as long as there is one user who has a link to the file or the original file itself exists. The hard links will ensure that you don't lose that resource until the last reference to it has been dropped. Yeah, okay. For those of you going on to a second semester Linux course, there will be some additional content about linking that's beyond our scope. So there is an issue. You can only link within a single file system. You can't link across devices, for example. So if you were to attach a backup device, you can't hard link from the backup device into the host device. So hard links have some limitations. I don't actually find myself using them ever, but they're there, which means that people do use them for some things. Okay, so that's hard links. So I'm back in my week 15 folder. I've erased all the stuff, so I'm going to go ahead and make, I'm going to remake file 1. It's going to be a brand new file. I'm not linking it to the other reference to the old file 1. That's a completely new file. So this time we're going to do soft linking or symbolic linking and then explore the differences. So in a way, a hard link and a symbolic link will allow you to place shortcuts to resources in various places on your system, and that's super handy. It's handy to be able to store a file or a program somewhere on your system and then link, hard link or soft link it to your users as an example so that they can collaborate on it. And you can do that with either kind of link, but there's an interesting thing about symbolic links that is different from hard links. So let's look at the inode. There's the inode value. It's a different one from the original file 1 because it's a brand new resource because I deleted the original and remade it. All right, so let's make a symbolic link. So that's what I want to link to. The link name, I will call it link1 again. and then I'm going to do a long listing. And one thing that, at least on this system, the default in a long listing is to actually show you the symbolic links in terms of what they reference. So this is saying that link1.txt is actually a link to file1.txt. Let's look at the inode values. So here's a big difference. Symbolic links are different resources that happen to refer to things. Hard links are literally the same thing. In a hard link, as long as you have one hard link or the original resource, you can delete things and the original data won't go away. But symbolic links can be broken. So hard links can't be broken. Symbolic links can be broken, meaning that the thing that they link to can be taken away and the link now doesn't work anymore. So before we do that, let's just use the link to access and edit the file. All right, so here's the file. So this time I got here, let me delete that extra. I got here using a soft or symbolic link. I did a VI command on the link just as if I were working on the file. And because the link refers to the file, VI knew to open up the file. And I'm editing it. All right, so clear. Let me do the inode numbers again. So symbolic links have their own unique inode. And why this is important is because you can break a symbolic link by removing the thing that they refer to. So I'm going to remove file1.txt. It's gone. You'll notice that the link is now unhappy, but it still exists. So the link still wants to refer to that file1.txt, but the thing that it was linking to no longer exists. And if I try to edit it through the link, it has no choice basically but to try to open a new file because the original one is just gone. So I hope I'm not I don't want to go so far as to make it confusing, but I also don't want to stop short and leave it confusing. So hard links are both kinds of links give you a way to access a resource somewhere on the system. And what we often will use links for is to create a link, symbolic or a hard or soft link, somewhere on the system that refers to something that we have installed somewhere else on the system. I personally use this in my programmer toolkit. I might have, for example, multiple versions of a programming language toolkit, and I will create a symbolic link to the version of the toolkit that I want to sort of currently be using for my projects. Yeah, so the reason why we would use soft links so for me, so it's a good question. Someone asked in chat, why would we even use a soft link? So for me, I think of a soft link as the same thing, the same concept as a shortcut on a Windows machine. So you really just are using a symbolic link as a convenient way to access something somewhere else on the system. And the nice thing about the way it just feels natural to me that a symbolic link, you can just kind of move it around to point to, say, different versions of a set of software that you have multiple versions installed. Then you soft link to the current version, and then when you want to change versions, you move the soft link to refer to a different version. Which is just, so for me at least, conceptually, soft links are the ones that kind of make sense for that. They are just links to things. And if the things go away, then the link breaks, and that's okay. I'm not really worried about losing data in that case. I'm just sort of using the symbolic link as a handy shortcut. A hard link would be more in that case where I want to have multiple people kind of accessing and working on this file, but I also want to make sure that should people be dropping off of the project, as it were, that I don't lose the original data. Um, anyway, so I hope that makes sense. More technically, symbolic links, if you have, let's say, an external backup system that you have connected to your Linux system, file system, so you have kind of your regular hard drive, and then you have, just to simplify things, an external hard drive that you are using, you're accessing data from both on your system. You can't hard link between those two different devices effectively. Now I'm simplifying a little bit just to make this, hopefully make it more understandable. So I can't hard link across multiple devices, but I can symbolic link across multiple devices. So sometimes the reason why you use a symbolic link as a system administrator is because you won't be allowed to hard link across devices or systems, whereas you could symbolic link across them. So symbolic link, I don't know. Hopefully that kind of helps a little bit. Like I said, for me, I never use hard links. Never use hard links. I've never encountered a situation where a hard link made any sense to me to use, because I'm usually linking, sort of conceptually, I'm linking to make shortcuts to things. And that's kind of what symbolic links are naturally good at. Okay, anyway, if I touch file1.txt, by the way, to recreate it, let's see if the link comes back. Okay, so the link actually will find the newly created file1 and relink itself to it. They are still unique inode index values. So yeah, that's kind of hard. Okay, thank you, that one kid. I'm glad that helped a little bit at least. A link is a link is a link. There are kind of hardware limitations when it comes to linking something from one device across to another device. Then you have to use symbolic links. To me, I've always kind of known that symbolic links make sense for creating shortcuts to things. They are just kind of a convenience. Whereas hard links are kind of, at least the way I imagine them being used, is that you're being intentional about your desire to create multiple points of access to a resource, and you are being intentional about your desire to not have that resource be destroyed as long as someone is still maintaining access to it to work with it. It's kind of how I think of it. Okay, anyway, so that's linking. We're really just kind of getting that quick view of it so that you know it's there. I think it's probably somewhere in our course outline of record. That is the reason I talked about it. And if you go on as a system administrator, you will want to know better how to manage this linking problem. And then you'll get more of the gory details about when hard links and symbolic links make more and less sense, I hope. Okay, so that's linking. Let's move on to dev null. So yeah, I will introduce dev null first, and then we will use it in context. So dev null, some people call it the black hole. So dev null is literally just a place where you can send system output that you don't want to look at. And we're going to see a lot of this when we do find operations. But we'll just do a real quick example first. So if I do echo hello, that by default comes out on the screen in front of me. But if I redirect it to dev null, it just goes down a black hole and it's lost forever. That doesn't seem like it would be useful with an echo statement, because it isn't. But it is useful for things like finds, and I'll show you that in just a second. So dev null is on the system. It is a black hole that we can use to direct output that we don't want to be bothered with. And I'm about to show you that in just a moment. So anyway, dev null, it's a black hole. We use it when we don't want to see garbage on the screen. When we do want to see garbage on the screen, then we don't black hole it. Okay, but it's going to come up in a second when we do a find, and then we'll see how dev null is very, very useful. Okay. So let's do find, and then we will come back to dev null, where we will see a use for why would I ever want to black hole some of a command's outputs. Okay, so find is a way to search for files. You have these utilities on your Windows system and you have it on a Mac. Find is actually very, very powerful, but it's also one of the more difficult ones to get comfortable with. And I have friends who are like pro find users who can do way more things on it than I can. But I can use find for kind of all of the most important, at least in my opinion, kinds of things that you'd use a find for. So it's simply a way for searching through your file system for something. Let's go down a little bit and ask the question, what are those kinds of somethings? We're not going to bother with the options. What we are going to bother with, though, are expressions. So we will use find expressions to target specific ways of finding files on the system. Okay, so I'll tell you when I get to one that I know we're going to use. So there's depth. There's not finding on unmounted file systems. We are going to use this +n -n syntax, and you'll see that in just a moment. But I'm going to go down until I find an easy one to deal with. Okay, right here, -name. So we can search for files by name, which is, for me, the most common way of doing that. So we do find -name, and then we give it a pattern of the thing we want to look for. Base of the file name, so matches shell pattern. Anyway, if we want to find things by the name of the file or directory, then we would use the -name argument. So -name, and then we'll come find a few more. So I'm going to go back up to the top here. Sorry about I hope I'm not making anybody seasick. So we'll start with -name. And I guess I could have just shut it down. And okay, so we're going to use it like this. So we're going to use find. And then you see that starting point option. We're going to go ahead. I'm just in the habit of always doing this. I always supply the starting point, which is the little p path starting point that you want the find to work from. And then followed by an expression, which for us is going to be, we're going to be looking for a file of a particular name. Okay, so let me go back to my home directory. And let's just see if we can do a find starting from the present working directory. I could do the dot by itself, but I want to make it clear to you that my starting point is the present working directory, which is home jpoit. I'm going to be searching by name, and I'm going to be searching for things that have file at the front of them. Okay, so here's already a case. I'm getting a permission denied, and that's because week 12. That's interesting. Do I have a hello in here anywhere? No. Do I have a hello.sh somewhere? I do. Okay. So do I have a file1.txt somewhere? Yeah, I have a couple of those as well. So you can see kind of here the basics of how a find works. So our starting point is the present working directory. So here on down, the name I'm looking for in this case is file1.txt, and I get a permission denied. Okay, so permission denieds are usually something in a find that I want to be able to ignore. I don't care about the permission denied, and let me show you an example of why the permission denieds can be so terrible when you're doing a find. So I'm gonna start my find at the root of the file system. And here's why permission denieds can be so irritating. Because if I'm doing a find anywhere in the file system, there's a good chance that a whole bunch of the resources, I'm not going to have permission to read them because I'm a regular user and I don't have permission to read many of these things. So how do I get rid of all that permission denied crud while keeping any of the good results? Well, we'll build up our argument this way. So we need to do a black holing. So black holing is a way to get rid of all the permission denied errors in this case. We can get rid of all the stuff we don't want to see. Now, the way I'm doing it right now is not correct yet. But basically, we can take all of the output. Oh, that was only the regular output, wasn't it? Yeah, that was only the regular output. So that actually, by the way, yeah, that probably just took away all of my good output. So let's take away all the bad output. And this I haven't shown you yet, but if we put a 2 in front of the greater than, that in theory is all of the error messages, which is all the permission denieds, being dropped into that black hole. So we love dev null with find because all of the errors, which is why there's a 2 attached to the greater than. So we want to take the number 2 represents all the errors. I think, by the way, the number 1 is probably the regular stuff, but let's try it out just to see. So we'll call that good.txt. So number 1, I think, is the good stuff. So let's look if the good stuff went in there. Yeah, so number 1 is the good stuff. I believe that if you take the number 1 off, that's defaults to the good stuff. Yeah. Okay. So redirecting with just the greater than just redirects the good stuff to a file. If instead I redirect to /dev/null, that redirects the good stuff down that black hole where it's just completely lost. If I redirect 1 somewhere, like the black hole, then that's all the good stuff. So the default is the good stuff, but I can say specifically the good stuff, or I can say specifically the bad stuff, which is the errors. So hopefully that makes sense. I have this find command, so I'm find starting at the root folder. I'm looking for things that have the name file1.txt. I am wanting to take the errors, that's what the number 2 means. I'm wanting to take the errors and redirect them to this black hole because I don't want to see them, I don't want to save them, I just want them gone. So I will redirect the errors only, which means that any good output will just appear on the screen in front of me. So love this dev null thing for that. Okay, so we can also do sizes. So let's bring the man page up for find. We can also search by size. So I'm going to search the man page for, can I say dash size? Yeah. Okay, so I can search by size, and there's that n. So if I do a dash size, then I have to provide it an n, which is a target size. And the target size can be specified by its increments. And what I mean by that is that n can be how many blocks, how many bytes, how many words, kibibytes, mebibytes, and then gigabytes. I just sort of think kilobytes, megabytes, gigabytes. So little k, big M, big G. So we can say I'm looking for things of a size in kilobytes or megabytes or gigabytes roughly by providing that number n followed by the letter. Now that n can also have a plus in front of it, which means I want to find things that are bigger than this. The n can also have a minus in front of it, which says I want to find things smaller than this. Or the n can just be a number, which means I want to find things that are exactly this. So let's try a find. So let's make sure I'm in my home. So I will find, starting in the present working directory, I'm going to look for things that are of a size that is let's say greater than 1 kilobyte. I may not have anything of that size. I do have things of that size, as it turns out. A lot of stuff, in fact. It looks like a lot of caching from web browsing activities. Notice there's a lot of folders. So I have a lot of folders that have more than 1 kilobyte's worth of data in them. Let's see if we can find things that are... Do I have anything bigger than 1 megabyte? Oops. Permission denied. I don't want to be bothered with that. So I'm going to take the error output. I'm going to redirect that to a black hole. Okay. So I have some probably graphical desktop cache information that's quite large. And I doubt I have anything, but I can. So of course, if I go to the root folder, I'm probably not going to have permission to look at anything that's not my own stuff anyway. But let's try it, and we'll redirect the error to dev null. So I'm gonna try to find at the root folder. Same search, anything greater than 1 megabyte. In fact, let's say anything greater than 10 megabytes, roughly. Whatever errors happen, send them into the black hole so I don't have to look at those. Let's see if there are any. Yeah, there's a bunch. There's a bunch of these .sos are library files that software uses on the system. There's a proc kcore as a folder that's greater than 10 megabytes. So anyway, size is kind of cool. And I was using the plus here to say things that are bigger than 10 megabytes. I could also say things that are less than 10 megabytes by putting a minus in front of it. And maybe I can say exactly 10 megabytes. Or that's probably also bigger than 10 megabytes. No, that's probably maybe kind of roughly exactly. Okay, so there's a size search. We can do a type search as well. So let's, man page, we will search for -type. I'm using the N for next. Okay, type. So I give it -type, and then I fill in a character for the type I'm looking for. So for example, I can look for things that are directories. I can look for things that are regular files. I can look for symbolic links on the system, which I might do just for fun. And also try the directory one. So let's do a find. We'll start at root. We will look for things that are type symbolic links on this system. And anything that would produce an error, I'm just going to black hole it. So I'll look at whatever the good results are. So I'm looking for anything that's, any resource that's a symbolic link. There aren't any. Oh, wait, it's not a -L, it's just an L. Okay, there's a lot. There are a lot of symbolic links on this system. You'll notice that the system itself is just using them all over the place. These things that say .service at the end are software subsystems that are usually launched. Probably most of these are launched at runtime, or when I launch a graphical desktop, then a lot of these services will start running to support whatever it is that I'm doing right now. So notice that a lot of the services are actually symbolically linked somewhere or from somewhere. We can also do, so I'll just use my present working directory. I will just list out directories only. I'm going to have one that's an error here, by the way. So these are all my directories. One of these is going to, yeah, there's a permission denied. See it? So we will take whatever errors and black hole them, which is mostly the same, but the permission denied is not gone. Let's see if we can also say things that are bigger than a megabyte of that type. I don't have any. How about bigger than a K? Yeah, a bunch. How about bigger than 10K? None. Bigger than 5K? The thing I'm showing you here quickly is that you can combine these searches. So I can say of this size, of this type, of this name. You can combine all of them into very fancy finds. Um, and then, oh, we have M time and user. So go find, I'm doing okay on time. So the way I'm searching with the man page, by the way, you may have noticed. So once I've got a man page open, if I type a / you'll see that there's a thing at the bottom of my screen where it's waiting for me. There's the /. So I'm going to type in what I want to find, -M type, and then I'm going to press enter. And it didn't have a -M time, so why not? Oops. M time without the dash. Yeah, so for some reason the dash wasn't going to work for this. So I just did M time, and there's the first one. And if I type in N now, it'll go to the next M time. So I'm going to keep doing this until I find the lead. There's only one of them. Okay, here it is. I typed in again. Here it is finally. This is the one that I want. So anyway, you can do searches in man page with / what you're searching for, and then next. So M time. So here's another N. So the N here is file data that was last modified more than or exactly N times 24 hours ago, meaning days, right? So you can say plus a number of days, which means more than this number of days, less than a number of days, or a number of days ago. All right, so you can also, this would be good for probably forensics. So finding things that were altered. So M time means the last time a file was modified. And that might be a good way to hunt down malicious activity is nobody should have been touching anything. Or is there anything that's been modified in the last day or two? So we will find. We'll just look in my own home directory. We will look for a modification time of greater than 7 days. So it tells you N, the 7 times 24 hours. But anyway, that's the number of days. So I'm looking for anything in my folder that's been modified more than 7 days ago. And I know there's an error comes from somewhere, so I'm going to go ahead and black hole it. So there's a lot. A lot of these things were not altered anytime recently. They were, all of them altered more than 7 days ago. Let's try more than 30 days ago. That's a lot less. How about more than 60 days ago? Makes sense, right? Week 6, week 5, week 3, week 2. We can also say clear, so find from here a modification time that was less than 3 days ago. Let's go ahead and redirect any error output to dev null. So this is all the stuff that was modified 3 days or less than 3 days ago. Some of them are graphics configuration stuff, and then some of them are things that I have modified within the last 3 days or less. So that's the M time thing. The last thing, so find is really, really cool. If you can become an expert in it, by the way, you can actually do a find command that will execute commands on the found things, which I think is super, super cool. That my pro sysadmin friends can do that. Okay, one more find. So -user. So / to search for -user. Yeah, so you just put in a username. So file is owned by a particular user. So I'm going to go ahead and search in the entire file system for anything that I own. And I know I'm not going to have permissions, so let's take the errors and redirect those to the black hole device. So there's all the stuff that I own, which is a lot of stuff around the system that I never directly touch, that the system has been creating for managing data for me, but I still own it. So anyway, I own a lot of stuff on this system. Not just stuff in my own folder. So anyway, those options I just think are kind of some of the more immediately useful finding options. And then, pardon me, I'm just going to do for a few minutes a quick talk about what the hands-on experiment is going for here. So one thing I like to do, and let me just think of a find. So let's just say, for example, I'm going to go ahead and, yeah, let's do the whole setup. So let's just do the whole setup. So I'm going to get to my home directory, and I'm going to make a file called .bash_functions. The dot, of course, just makes it a hidden file, meaning that a regular listing won't show it. .bash_functions is not a built-in thing. I'm just making it up right now. But what I like to do here is I actually can program some shell functions that I can use as commands from the command line. So this is another feature that we're going to explore in the bash shell just for a few minutes here. That's another way that you can customize bash. So you can customize bash by changing the command prompt PS1. You can create aliases so that you have commands that are kind of aliases for variations of that command. You can create shell scripts, which are kind of like little shell programs. And you can also create shell functions, which are kind of shell mini scripts. Or I think of bash functions as really just custom commands that I create. And I don't mean shortcuts to other commands. I mean custom commands that kind of do something fancier than the normal thing. And I'll show you what I mean by that here in just a moment. So anyway, in this .bash functions, I'm going to create functions. You can see that in the, okay, I still have it open. I'm not going to switch my view, but anyway, this is what I've done in a lot of the hands-on experiments is I have created some functions and a setup for them. I'll do one of the examples, but I'm also going to do my own little example. So yeah. Anyway, so this is another shell customization feature, and what you can do is you can actually insert escape insert. You can create functions which are like your own miniature localized utilities. So I'm going to make one called big files. I didn't switch the view on you, did I? No, okay. So I'm going to make one called big files. So we will use all the same tricks that we would use in a shell script, but think of this as just I'm kind of creating my own little miniature utility for my own personal use in my own home folder. So big files. I'm just going to do this. Find, starting at my own home directory, anything that is a size that is greater than, let's say, 10 megs. And I'm going to go ahead and use the black hole trick here too. So now I have what I'm going to end up with ultimately is a command called big files that if I type that at the command line, it will actually execute this function in here. And then I'm going to enhance it and then do one other thing I think will be good. So how do we use this .bash_functions? So there's my function. I'll go ahead and do a write on it so you can see where it went. I saved it in a file called .bash_functions. Why .bash_functions? Because these are bash shell functions, but also because that will help me know when I do a long listing, rather an all listing, and I see .bash functions, I will be reminded, oh yeah, you made a file called .bash_functions in which are bash functions. So what you're seeing on the screen is a bash function. How does it work? So we will save it. We will source it. Which means that we will load all of those function definitions into our shell environment. So you can think of these functions as just kind of miniature scripts, but they give you more of the programming power than an alias. So you have the alias, which is really just kind of a different way of wording a command, like a shortcut. And then you have a script, which is a whole bunch of stuff. And then you have in between those a function, which is kind of like a script, but not typically as big, kind of tends to be fairly small, but more than an alias, because often we will end up doing a little bit of programming in our functions. But anyway, to get a function to work, you source a file that has functions in it, and then you have access to them. It turns out I don't have any big files, but I'm going to go ahead and enhance this to allow for arguments and also to print some information on the screen. So we will go back. Let's edit it. So I'm going to put an echo statement in here. So this is not the kind of thing we would do with an alias. So kind of like a script. So I'm going to enhance my little function by putting a little echo statement so that when I run the command, and it's going to say files greater than 10 megabytes, and then it will actually execute the find command and print the results for me. Okay, so just a little echo statement. I'm going to write and quit that. I have to resource it to reload the definition in. Now when I type big files, it prints files greater than 10 megabytes, but roughly, but there weren't any. So that's fine. Let's do one more enhancement to this so that you can kind of see where the experiments are going. So I can do this. Oops. So let's look at the number of arguments, and if we get 1, then we can do all this stuff. So anyway, okay, so let me go fix this one. So what I'm saying here is that I'm going to enhance this function to be kind of like a little miniature script in that it can take a command line argument. So I'm looking for exactly one command line argument, which will be the desired bigger than size that I'm looking for. And I'm actually going to plug that value in, reviewing from last week, using the first command line argument. So things that are greater than whatever they said they're looking for on the command line. And then in here, I should be able to, although I should quote this. Probably that's not going to matter, but it might break things. Let's not do that. So let's see if this works written like this. I think it will. All right, anyway, so this is what I'm talking about, kind of between a script and an alias. So you couldn't do all this programming work in an alias. But for a script, maybe this is more than is needed in a script. Why not just kind of have this loaded into my shell environment as a function? That takes an argument. So let's try it out. This is very similar to something in the hands-on experiments, if not the exact same thing. So you'll see this again if you do the hands-on experiments. So I'm checking the number of command line arguments on line 2. And then on line 4, I'm printing out that number, $1. That's the thing that the first argument they provided. And then on line 5, I'm actually using it mixed into the find command to be greater than that number that they supplied as their first argument, megabytes. All right, so I will source it again to load the newest edition. If I run it with no arguments, I should get a usage. So, oh yeah. Oh, except for it says bash. Well, I don't want bash. Better fix that. Okay, so the usage couldn't use the $0 because the function is running kind of as bash. So I'll say, oh, you need to run this command with a size. So save that. I will resource it. And then I will rerun it with no arguments. All right, that's the usage message that I want. So if I say big files 10, so there aren't any greater than 10. And notice that it plugged in the 10. If I do 5, I don't have any that are greater than 5. How about 1? Okay, I do have a couple that are greater than 1 megabyte. So this, I've made myself a little flexible command line utility. So the last thing I'll do, because I've run this over a little bit, is how do I get these functions to just load into my environment automatically every time I load into the system. So the way I would do that, so I want my functions to be sourced in automatically, more or less. I'm in my home directory, so I'm going to go to the bash rc file, and I'm going to go down to the bottom, which I know I could do big G. Go down to the bottom, and I'm going to source it here. I'm going to be careful, by the way, and make sure that I'm being clear that it's my home directory. That's why the tilde is there. .bash functions. So this is my .bash rc file. And what this means is that every time a non-login shell is open, which is what will happen when I'm in this graphical environment, my functions will automatically be loaded in for me. I'm going to get rid of this line. It doesn't need to be doing that anymore. So you can do source tilde, meaning my home directory, that folder, that file, .bash functions, and then every function in there will be loaded into my environment. W, so that's bash rc, which is sourcing my bash functions, which means that I get all that work that I did loaded in. Let's put one more function in there to test the sourcing, so I can do more functions if I want. Oh, I don't know. I'll kind of do something a little bit like, oh, I know what I can do. All right, so I'm going to have a cal shell function, and I will say if they provide an argument, then I will cal say that argument. I'm going to quote this one. I think in this case, hey. I'm going to quote it that time. Else backtick date. So again, this is a little bit more than I could do effectively with an alias because I have this decision making. But now I have a second function called cal. If they provide an argument, then I will cal say whatever that is. Otherwise, I will cal say the date. So that's my bash functions. And now the big test, which is I'm going to close this. I'm going to reopen it. And hopefully, my cal function has been loaded in. There it is with the date. There it is with a message for you guys. So anyway, that's more of that to be found in the hands-on experiments for the week if you want to know how to use bash functions. It's a little bit of bonus material. there's no questions about that on the lab. But for those of you who want to dig in a little deeper, I wanted to offer that to you. So that's it. One more week of new content. Next week, we've kind of left some of the less nice looking stuff till the very end of the semester. So it's cool stuff, but it is some sort of technically some of the more challenging things. So that's what's happening next week, and then the week after next week is the week of the final. So anyway, there's good stuff to be found next week, in my opinion, but it is technically more challenging. So we've kind of waited until we've had a chance to kind of practice all of our command line skills, and then we'll do these slightly more technically challenging things, which are super cool, for the last week of new content. Okay, I think that's it. Thanks for being here for the live stream. If you were able to make it, thanks for watching the video if you're watching it later. Otherwise, next week is the last week of new content. The week after that, review and final exam. The big thing this week is the distribution project. It is due on December 4th. So best if you don't, of course, wait until to start until late Sunday night. Best to not make that a stressful experience, I hope. So good luck with that. Canvas inbox, Piazza, office hours are all available if you need to ask questions of me or your classmates as you work on the distribution project for December 4th. Okay, thank you, that one kid. You have a good day as well. And I'll see everybody on, see as many of you as come to the live stream on Monday morning next week. Have a good week.